In this problem, we're given the equation y equals 3 times the quantity x plus 1 squared, subtract 5, and we are to match the function with its graph. So to explain the goal of this problem, I went to the internet to a website called Desmos.com. I'm currently graphing y equals x squared. I've done this because it's the parent function of the one given in our problem. So if you're on the section on transformations, the goal would be that you have learned that if you replace x with the quantity x plus 1, it turns out if you add 1 to the input of the function, or if you will, add 1 on the inside of the function process, notice that it shifts the graph to the left 1 unit. So the red graph is the original y equals x squared, and I've done nothing more than replace x with the quantity x plus 1, and that shifted the graph left 1. So any of these choices down here for which the graph did not get shift left 1, such as this one and this one, we can throw out right now. In fact, it looks like they shifted the graph to the right 1 instead of left 1. Now the question is, what does the 3 in the equation do, and what does the minus 5 do? And I'm about to show that, but notice already I can tell you which graph matches the given equation then. The fact that there is a 3 outside the quantity x plus 1 squared, and 3 is positive, you may know that that means that the parabola should open upward. So it turns out that the first graph would be the correct answer, because the second graph has the parabola opening down. So there's a little more to learn here. I'd like to now show you what the factor of 3 and the subtraction of 5 does to the graph. So now what I've done is insert a factor of 3 in front of the quantity x plus 1 squared to show you that the factor of 3 does nothing more than vertically stretch the blue graph. So remember that y equals x squared, the red graph is my parent function. Replacing x with the quantity x plus 1 moved the graph to the left 1, giving me the blue graph. Then, comparing the blue graph to the purple, putting in a factor of 3, vertically stretched the blue graph to obtain the purple graph, which basically made the parabola narrower. Then, let me take the expression here and subtract 5 to then show that the purple graph gets moved down 5 now that I've inserted the subtraction of 5. So to summarize, the plus 1 inside the squaring process moved the red graph left 1 to obtain the blue graph, and then the factor of 3 made the graph skinnier, so to speak, or vertically stretched it, and then the subtraction of 5 moved the graph down 5. Now it's just a matter of you comparing the purple graph here on Desmos with the problem given in Math AS.